Okay. Hello, everyone. Welcome to the session OpenTelemetry Collector in Splunk. Thank you for joining. So, here we'll discuss about introduction about myself and what is OpenTelemetry and the components of the OpenTelemetry and the use cases, and we'll wrap up with a small demo. So, coming to the introduction. So, I am Venkatesh, this Splunk consultant at Bitsio. And my main focus over the last couple of years has been helping customers to get the data in, configuring the cloud and on-prem clustered environments, and helping the customers with the data migration. So that is about myself. And the second thing is the workshop, what we are trying to do, or the user group. In this user group, we'll be focusing on using the OpenTelemetry Collector and starting with the fundamentals of configuring the receivers, processors, and exporters ready to use with Splunk Observability Cloud. So now let's go to the next slide. What is OpenTelemetry? So OpenTelemetry is an open source observability framework that helps you understand the performance and health of your cloud native apps and supporting infrastructure. Usually we call OpenTelemetry as OTel2, and this is a vendor agnostic or vendor neutral API. So OpenTelemetry has been around for a while, but it's really quite a change. It's changing from starting to now. It's standardizing the industry when it comes to the instrumentation and data collection aspects of your observability data. So now these are called signals in OpenTelemetry, but you can think like traces, metrics, and logs. But it's more than that as well. Like it will support real user monitoring. It supports profiling, synthetic information. All of this would count even if it is from the mobile devices. That's one of the main advantage of using Hotel. All of this data is relevant. You need an end-to-end visibility of your environment to understand both availability and performance problems. So OpenTelemetry is really worried about the instrumentation data. Sorry, worried about the instrumentation and data collection aspects here. So it provides an open standard that you can leverage to send your observability data wherever you want. The goal here is to so the goal here is that you will have a single way to do this. So instead of installing multiple different instrument libraries or using proprietary solutions, you can have a single solution that will adapt over the time to the new standards that comes out, and it supports for new vendors, and you will get benefit from using this open telemetry. And as I said, it's entirely vendor agnostic, right? So so this is part of the Open Telemetry or OTel. It's a part of the CNCF or Cloud Native project, and it is an open source project with others like Kubernetes, Prometheus, probability that you heard, the probability that you heard before, and Open Telemetry is the second most active project in all of CNCF, behind only Kubernetes. Okay. So now let's discuss about the components. Here I'm not showing all the components. I'm just showing only the hotel collector. So we are going to be focusing primarily on the collector, but I did want to talk about the architecture really quickly. So if you think about your environment, you have a bunch of data that you are trying to collect, and you probably have different variety of environments you are trying to collect it from. So for example, you might have a virtual machine or the containers. Maybe you have a microservices, or maybe you have a monolithic, they are running on some of the infrastructure. Maybe it is on premises, maybe it is from the cloud provider. You could be using orchestration things like Kubernetes, or you are connecting to a third party services, maybe through API calls. All of that data needs to be collected in some way, and that is what OpenTelemetry is trying to provide answer for. So whatever the data you collected from shared infrastructure, microservices, third party APIs, all of this is collected through the hotel collector. And this hotel collector is divided into three parts. Let's discuss that one. So, so why it matters? All right. So until now we discussed about the hotel, and what are the things you want to onboard into the observability using hotel. So why does OpenTelemetry matters? I'm going to answer this primarily from the data collection side. So basically, you when you use hotel, you have control over your data of what you are trying to ingest, how you are process it, and where you send it. And if you want to change any of that, you have that right. So a great example here is, maybe you want to enrich or redact information about information that you are collecting before you send it to your observability platform. You can do that with the collector. You want to receive in one format but export in a different format. You can do that with the collector. That's the power here. Like, you can control what happens with the data that you are generating, and also how much you are generating, how much you enrich. So in this picture, you basically have a very high level diagram of hotel collector. What's made up of several components, but here I'm showing only the three components, primarily receivers, how you get in, and the processes. What do you want to, what do you want, sorry, what do you do with the data? And once you have received it, and then it exports where you're going actually, where you are going to actually send it. So you can call, if you want to compare this with the universal forwarder. So the receivers is called the inputs, and the processors is called the props, and exporters is like output.conf. So where do you want to send? So that's how I compare it, but it's not the actual way, but that's how I'm comparing here. So here the powerful so now what's the powerful here is that you can build what's called pipelines in the collector, and that is in the processors. So you can see them in this diagram reflected with the orange and the green lines. If you see here, orange and the green lines, it's kind of hard to see, but they are behind the scenes. But the orange line here is showing you are receiving the data from hotel protocol, and you are doing some batch and attribute processor, and then you are sending to the Ager platform. Okay. So this would be a tracing use case. Or if you look at the green line, shows you are receiving OTLP batch, and receiving from the OTLP, and doing batch and filters, and you are sending out to the OTLP destination and Prometheus destination. OTLP and Prometheus destination. This would be a metrics use case. So what's Interesting here is you notice that one format in different formats sending through the transformation. So you have a flexibility to change however you want. Okay. So now let's talk about the use cases. Do you have any questions until here? I will show you what are the things you want to configure in the receivers, in the processors, and then the exporters, yeah, in the coming slides. Okay. So now let's talk about use cases. There here we have a bunch of use cases. I'm not going to cover all of them, but at a high level, this could be the front end problems that you are trying to solve, or the back end problems, infrastructure, could be the end user behavior. All of these things are possible for our availability and performance issues to solve within the open telemetry space. Okay, so now Splunk is heavily leverages open telemetry. In fact, Splunk Observability Cloud only uses open telemetry to receive data today, and its backend is optimized to it. So there are no proprietary agents when you use Splunk Observability Cloud. It is based on open telemetry. That is 100% sure. And on top of that, we'll provide some nice customization features. For example, we can do automatic deployment of instrumentation through data collector, and um, and this is vendor agnostic. So, so that's why it is more powerful here. Okay. Now, okay, this is so now what Splunk offer is called Splunk distribution. So I will explain you that in detail. So this is very common in open telemetry. You may be familiar with if you are using with Kubernetes as well. What a distribution is, it's taking the upstream open telemetry collector and it's wrapping up in a way that it makes it easier for you to use and consume with Splunk Observability Cloud. Basically, we add some things like some environment variables you can set, and if you set them, it will automatically configure the collector for you on top of what we have some ease of things like automation, automatic instrumentation that kind of mentioned that are fully supported by Splunk or by this distribution. So you don't need to configure anything. You just use this Splunk distribution to install an agent and to install an as an agent, and you can do that. Okay. So now let's talk about how you can control the data. So before that, so you can do this in a few ways, but let's talk about the topologies first. There are actually two primary ways you can deploy the collector. I'm showing the Splunk hotel character. Excuse me. Splunk hotel character collector. That distribution you can replace with just Splunk hotel character, and it is exact same thing. So there is no difference between the distribution that is supported by the Splunk and the upstream hotel. But one very common way to deploy the collector is an agent. That means as close as to the application. You might deploy it as a sidecar on the containerized environment, or you can deploy it as a daemon set, like per host, in case of the Kubernetes. So here example, if you have a host, it's only showing you one application, but it could have two or three, it doesn't matter. You have one single agent and on that host that allows you to push and pull the data into the collector. Okay. So for in the one application, and I mean one host can might have multiple applications in that, but it will send the data into the Splunk observability suite. And the second most common topology would be, let me go to the slide. Yeah, would be actually having a gateway, like a load balancer gateway that is clustered on that is clustered instance of the collector. So you have a load balancer in front of it. The use cases here include security requirements. We have seen cases where the agent is not allowed to talk to the internet. So you want to centralize things like API tokens. You can do that in a gateway mode. It can also be used for more advanced scenarios like filtering or aggregation capabilities. And other examples are in serverless environments, you don't typically deploy the collector, but maybe you want to have some instance, you can send the data to you, can do that in a gateway mode, or you might want to get data from certain endpoints like Kubernetes APIs where you only want where you want to collect only, you know, uh, one as a thing. Sorry, I mean, you want to collect only one time thing from the APIs, Kubernetes APIs, then you can use this gateway mode. Otherwise, you can use the agent. Okay, so as I described, we have receivers, processors, and exporters, and there are other different attributes, but we are not focusing mainly on, but we are mainly focusing on these three things. So in the receivers, we have Fluentd OTLP protocols where you can define the host metrics, and in the processors, we define the batches, resources and resource detections, and the memory limiter to save the memory on the collector, and where you want to send the exporters. All these things will be defined in the um, hotel collector, and these are all defined using YAML file. If you are using Kubernetes, you are know about YAML, and it is straightforward. Make sure you follow the proper format when you're defining it. Okay, so now let's go into a demo. So this is observability suite. So here, so for example, you have a Linux machine and you want to onboard, metrics data, trace data into observability. Then what you need to do is you need to go into the data management tab, and here you can do add integration. Click on- Hello. Okay. Yeah. So when you click on add integration, you can see deploy the Splunk Open Telemetry Collector, and click on it. And here you'll see the steps to configure it. So you can select the platform. If it is a Linux, Windows, or Kubernetes, you can select it. So I'm just want to deploy on the Linux machine. So deploy, select the Linux. And as I said before, there are two types of modes. One is as an agent, you can directly install close to the application, or as a gateway, you can install it. So these are the two ways or two modes of installing, but the common most way like using host metrics or agent. So you can test it. I mean, you can define the environment if it is a prod or if it is a test environment, you can define those things. And we are not discussing about the auto discovery mode right now. Okay. So, and the default tokens are already defined. So as an prerequisite, we already defined that. And you go to the next, you can install the script using this curl command, or you can use the Ansible if you want, and puppets, or you can have the Splunk add-on too. So whatever you want. So once you install this one, you can see these configurations are configured in the agent underscore config.yaml. So there we'll go there and then do a Splunk restart so that you can collect the metrics and traces data. But if you want to collect the logs, you need to have a Splunk enterprise, and you need to use. First, let me complete this, and then we can go to the logs later. So to do that, what we need to do is here I will copy this one. I'll copy later. But let me log on to this instance. Okay, so this is what I see. Or I can use this blank, and I can install it now either root or as a Splunk user. That's good. However you want. So I can copy this one and install that one, paste it. So it will install all the Splunk hotel collector. Or you can, if you want to use Splunk distribution, you can use this Splunk distribution, or you can use this OpenTelemetry contrib. So, you can download from here and you can install it, and you can configure it the way you want. So here it is, a detailed information is defined here, provided. So, and the contributors for this repository, you can see here who are all contributing. So it will show about the exporters, processors, and the receivers, and we have the connectors, all those things, but we are not going much into that, but we are going mainly focusing on the exporters and processor, exporters, and receivers. Okay. So you can use this as an installation method, or you can use Splunk distribution. So once this is done, it's taking time. So once that is done, let me open a new tab here. And once it is installed, you can see that in the infrastructure tab, since it is in the EC2 instance, I go to the next EC2 instance, and here I can see which instance it is. I think it's still installing. So here the instance name is, it starts with 8C12. There is nothing called 8C12. Okay, let's wait for a couple of minutes. Okay, so how we need to, as it mentioned in the documentation, we need to restart the hotel. Okay, it is restarted. Let's see now. It should show up as 4. It's still showing us 3. It takes a couple of minutes. In real time. Let's see. Filter it by. Let's first make sure the status of the Splunk hotel collector. Okay, it is active and running. That is good. Okay, still finger, but let's go here and just use the source. You see etc auto collector, etc auto collector. Change you can that agent config file. And as I said here, I'll go through all these things in a detailed way, starting from the receiver, processor, and exporter. Yeah. Just give me 1 minute to show the instance. Maybe the other thing, let's check this one. What is this? 682. It's up to my friend here. Just give me 1 minute. Trying to. Okay, I show you this one, but mm, see, mm, I see that. Maybe I need to troubleshoot. Oh yeah, now it's showing up. See if you see the infrastructure. Yeah, see now it's showing up. It took little time. So if you see here, yeah, if you see here, it's 8C12, and if you see here, it is this one, 8C12. So if you go here and if you click here, it will give you the total, traces for the CPU utilization, memory, disk, all those things, and you can set up the alerts if you want to. If you have certain thresholds, you can set up those alerts, And here we are not showing the logs right now yet, but I will show you how to onboard those logs also. And everything will be seen here, shown up here. So the other thing here is, let me go here. How I will show you how we are collecting the CPU, memory, disk, all those traces data. Okay. Okay. So I'm not talking about the extensions. Extensions is about the health of the hotel collector. So if you want to collect that particular parameter, you need to define these parameters, the health check endpoint parameters. So here I'm mainly focusing on the receivers. So if you see here in the receivers, we have host metrics. That's what we are collecting. And how often we are collecting is the interval is 10 seconds. For every 10 seconds, it will scrape us the CPU, disk, file system, and memory. So if you want, you can tweak these interval. And if you want to collect the data from the Fluent forwarder, you can use that one. Okay. So now coming to the and we have receivers, and we have this protocol. On this protocol, we are getting this data. So in the receivers, we have host metrics, we have Agar, we have OTLP, and we have Prometheus. If you want to collect the data, you can do that. In the processes, mainly process operate on incoming data to add metadata, batch it on the limiting the memory use. All those things we can define in the processors. If you see here in the process, so if you want to batch it, you can do using this particular attribute. And there is a memory limiter here where you can limit the memory of the collector, and you can override it. Which one? Yeah. So in the resource detection, so if you are you want to let here know that if it is collecting from the GCP, ECS, or EC2 Azure system, if it is a Linux system or anything, want to make sure you use this one. And and we have the, as I said, in the processor, we have the memory limiter, prevents the collector from exceeding the memory usage, and the default is 512 megabytes, and it's checked for every 2 seconds and drops if needed. Okay. So coming to the exporters, you can send traces data, metrics data, or logs. Everything we can send through the exporter. And if you want to send to the heck, you define the heck configuration, and we have OTLP gateway. If you want to send using that, you can do that. Like sending traces to the Splunk APM, we use this OTLP HTTP or a OTLP gateway. And finally, we have one attribute called services. This services defines how the receivers, processors, and exporters connect for each data type. For example, if you see here, for pipeline, we have traces. We have pipeline for traces. We have pipeline for metrics, and we have pipeline for logs. Everything will define here. So if you see here, we have our traces from OTLP. If you see here, yeah, OTLP, and it is processing, and it is um, then exporting to the signal effects, which is Splunk observability. So similarly, we have for metrics, and we have for logs. You see here, we have for logs too. And the other, if you want to send the logs, what you need is you need to have um, what is that? Log observer connect. Yeah, you need to define here the logs observer connect to send the logs. You need to click, add new connection. If it is from the Splunk cloud, you want to send the logs, or if you want Splunk enterprise. So you should have Splunk installed or Splunk configured as an enterprise or cloud. Then only you can send those logs to the Splunk observability. So you need to define few roles, you need to define few indexes, which indexes data you want to send it to the observability, and you need to configure the users, and you need to create a certificate. This is a bit lengthier process. We are not focusing on this right now, but if you want to do, you can do this one too. And you need to upload that certificate, and then whatever the account you created, you define here, and then click on save and continue, then you can see the logs. Yeah, any questions? Hmm, stop recording.